Welcome, dear learners. In today's class, we'll be looking at the concept of frequency distribution. So by the end of this class, you should be able to prepare frequency distribution table, determine the class interval, class mark, and class boundary for a given data set. You'll also be able to construct cumulative frequency curve. My name is Ademola Folarin, your delectable mathematics teacher. This tutorial is powered by IOTA Virtual Learning. So I urge you, let's learn together. For frequency distribution, basically, a frequency distribution table is a table that displays the frequency of each data set in an organized way. It displays the frequency of each data set in an organized way. So it always comes in form of table. We have it for group data and ungrouped data. So it always comes in form of table. The table shows the data set, that is the score you are dealing with. It shows the frequency, and it can also show something like cumulative frequency, class boundary, as the case may be. So for this, we are looking at a situation where we have group data. Take, for example, in a class of 70 students, as a mathematics teacher, you have given them an exam in which they can score between 0 and 100. And you have 70 students. Take note of that. So there are ways you can analyze it. It's possible that we will have a set of students that will score the same mark. So in that situation, it becomes a grouped data. You analyze it in group. So analyzing data in group calls for some concepts for us to understand, such as class interval. A class interval is a group or range of values which data is grouped. Group or range of values which data is grouped. So if you have a class interval, you are talking about scores of students from 0 to 100. You can have class interval of 0 to 9. Any student score 0 to 9 falls into this. 10 to 19. 20 to 29, and so on. So this is a class interval. Let's take, for example, we have it here, class interval. So if we are dealing with class interval of 0 to 9, 10 to 19, you write it this way. Then the next is what we call the class mark. Class mark. It is the midpoint of your class interval. Every class interval always have the lower limit and the upper limit. The lower limit and the upper limit. The lower limit is the beginning of the class interval, while the upper limit is the end of the class interval. So each class interval has lower and upper limit. So for the one we are dealing with here, now the class mark of this, to determine the class mark is always upper limit plus lower limit divided by 2. So here, the upper limit of this class is 9. The lower limit is 0. 9 plus 0, that will give us 9, divided by 2, 4.5. So that is the midpoint of this class. While if you do the same thing here, 19 plus 10, that's 29. 29 divided by 2, that's going to give you 14.5. So that's the class mark, which is also referred to as the class midpoint. And next is what we call the class boundary. Class boundary. Now imagine a block of classrooms. The end of one class, the wall that ends one class, is also the wall that starts another class. So in order to cater for the values that are not going to be wasted away, there is need for class boundary. They are the true limits of the class interval. They help us to remove the gap between consecutive class intervals. So that's the work of class boundaries. So that every value in a data set is catered for. To determine the class boundary, you remove 0.5 from the lower limit of a class. From the lower limit of a class interval, you remove 0.5 from the lower limit. That will help you to determine the lower limit of your class boundary. Take for example this. If this is 0, that's our lower limit. Remove 0.5 from it. It's going to give you minus 0.5. Now add the 0.5 you remove from here, add it to this place. That gives you 9.5. So that's the class boundary for this class interval. To determine the class boundary for this class interval, so we do the same thing. Remove 0.5 from this lower limit. Is going to give you 9.5. Then add it to this. That will be 19.5. So that shows the true limit of the class interval. That is what class boundary helps to cater for. So when you are dealing with this, you need all this. Then we talk about its frequency. That is the frequency of each value, the frequency of each class interval. So in the score of 70 students, let's say about 3 people score between 0 and 9, their frequency will be 3. If about 7 people scores between 10 and 19, we have a 7 frequency, and so on. Some frequency distribution table may even require what we call cumulative frequency. Cumulative frequency. Basically, that deals with adding frequency of classes together. Take for example, here is 3. You write the cumulative frequency 3. You will now add the frequency of this class to the next one here. That will be 10. So this 10 is going to be added to the frequency of the next class that follows this, whatever it is, and so on and so forth. That's how we get cumulative frequency. To the extent that the last value of the cumulative frequency here must be equal to the total number of data sets that you are considering. So let's move forward to take an example on this problem. Let's move forward to take an example. Let's look at this example. The ages of 50 teachers in a school is what is given below here. The ages of 50 teachers in a school. This one now, you are giving this data set in a raw form. I intentionally want us to use this so that we can understand how it is done. The question is asking us to prepare a frequency distribution table considering a class interval that has been given to us, and at the end we are also to draw a cumulative frequency curve for this distribution. So since we are dealing with cumulative frequency curve, our frequency table, because this is a raw data, our frequency table is going to be grouped or constructed in such a way that we are going to have, let's do it this way. We are going to have the column for class interval, which is what that one has been given here. We'll just put it in the column. We're also going to have column for tally, because we are the one sorting the data ourselves. We have column for tally. We have column for the frequency. Then we have column for cumulative frequency, because we want to draw just cumulative frequency curve. We have column for that. So this is how we are going to prepare the data. Now let's put those things in their various headlines. We have class interval, followed by tally, followed by frequency, then followed by cumulative frequency. So those are the ones we need. These are the tables we need, the column we need on this table. So to do this, we're going to do it fast. For the very first one, let's first put all this into their class interval. The class interval is 21 to 25. So the next one is 26 to 30. The next one is 31 to 35, followed by 36 to 40, followed by 41 to 45. Since 50 is the highest in this score, so it's going to be 46 to 50. That is the class interval. Remember, here is the lower class limit. Here is the upper class limit. So we are now going to look for this. Tally, we look for how many scores are between 21 and 25. 21 to 25, let's look at it. 1, 2, 3, 4, 5, 6, 21 to 25, 6, 7. So it's 7. So using the tally 1, 2, 3, 4, 5, 6, 7. So that is we have 7 for this. We'll put it there, 7. And you look for others too for the sake of this. Check. So for the 26 to 30, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have just 11. Look through that. You can pause this video and look through. So we have 11 for that. We have 9 for the following, the next one. 1, 2, 3, 4, 5, 9. For 36 to 40, looking through, we also have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. So for the next one, 41 to 50, we have just 6. 1, 2, 3, 4, 5, 6. And lastly, we have 8 for 46 to 50. 1, 2, 3, 4, 5, 6, 7, 8. So remember, the total is 50 that we are dealing with. So if I write out this, we have 11. That's the frequency here. 9 here. 9 here. 6 here. 8. At the end of the day, the total number of frequency here must be 50. If you add it up, this is 20, 27 plus 8. That's 35 plus 15. 50, yes. So your cumulative frequency will also help you to confirm if what you are doing is right. Look at how cumulative frequency works. The first one is 7, right? 7. 7 plus 11, 18. 18 plus 9, 27. 27 plus 9, 36. 36 plus 6, 42. 42 plus 8, 50. So the last value here must also be equal to the total number of data sets you have been given. So here we have been able to prepare what we call the cumulative frequency table for this question. The next for us is to look at how we can then draw cumulative frequency curve. Cumulative frequency curve is a data presentation graph where we plot cumulative frequency against the class boundaries, where we plot cumulative frequency curve against the class boundaries. So for the sake of that, we need class boundary. We may put that here, class boundary, class boundaries. Remember, we've learned class boundaries. So let's determine the class boundaries for these. This is the lower limit, this is the upper limit. So the class boundary is going to be, we remove 0.5 from here, we add 0.5 to this. So this is going to be 20.5 to 25.5. So this one will be the start of the next one, 25.5 to 30.5. 30.5 to 35.5. 35.5 to 40.5. 40.5 to 45.5. 45.5 to 50.5. So this is how we form the frequency distribution table to allow us to prepare our cumulative frequency curve. Now that all these are set, we need to prepare our frequency cumulative curve. We prepare the frequency cumulative curve. So let's do that. So we have our graph, is always on our graph. Like I told us, frequency cumulative curve is that you plot the frequency, you plot the cumulative frequency of a data set against the class boundary. Plot it against the class boundary. So bring in our graph. This is my own graph here. In doing this point is my cumulative frequency. Okay, let me use red. Cumulative frequency. Cumulative frequency. And this is the region of class boundaries. So I want to plot cumulative frequency against class boundaries. Now, let's look at it. My cumulative frequency, based on what we have here, the highest is 50. So I can start that. To make it conspicuous, look at this graph. I can use two boxes for just 10, 20, 30, 40, 50. So I can say this is 5. So my 0 starts from here. But yet to write that, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That is it. So for the class boundary, the first class boundary ends at 25.5. It ends at 25.5. So I'm using the upper class boundary for each class boundary that we have. The upper class boundary, so here I can call this point now for my upper class boundary is 25.5. So to make it bigger, I want to use two boxes. The next will be 30.5. The next 35.5, 40.5, 45.5, then here is 50.5. So you know the point I'm referring to. Now that this is done, I'll then begin to pick value for each. I'll begin to pick value for each now. At the class boundary of 25.5, I have 7 as the frequency. So I'll look at where the 7 is located. This is 5. So 6, 7. 7 is here. The next, at this upper boundary of 30.5, I have 18. Look at where I have 18. 18 is here. The next upper boundary is 35.5, and I have frequency, cumulative frequency 27. Cumulative frequency 27. So this is 27. At the upper boundary of 40.5, I have cumulative frequency 36. 36. At the boundary of 45.5, I have cumulative frequency 42. 41, 42 is here. At the last one, the cumulative frequency is 50. So I have it here, 50. It gives us 50. So in order to plot this now, let me use green. So my curve, this is going to be freehand sketch, but you have chance to do it better. My curve follows. Like this. So that's the cumulative frequency curve. We have plotted cumulative frequency against the class boundary. So the upper class boundaries are what we use to bring out this. So the cumulative frequency curve, which is also called ogive, always end up forming the S type of curve. S curve. That is something it look like. So I intentionally make this so big so that my viewers can enjoy it. So this is how we prepare cumulative frequency curve for a given data set such as this. Cumulative frequency curve is used only for grouped data. Only for group data. So in our subsequent class, we'll also learn more about some other way of presenting our data, such as pie chart, bar charts, histogram, and the likes. So you've learned something. Each class interval has the lower class limit and the upper class limit. The lower class limit and the upper class limit. If you are to determine the class mark or class midpoint of each class interval, you add the lower limit plus the upper limit, you divide it by 2, that will give you the class mark, which is also the class midpoint. In our subsequent lessons where we'll be dealing with mean, median, mode of a group data, we'll learn better how to prepare our table for such calculation in statistics. So frequency distribution table is a table that shows how data sets are arranged in their own corresponding frequency. If you have enjoyed this, don't forget to subscribe to our channel and click on like button for more interesting educational videos like this. I am your teacher, Ademola Folarin. Till I come your way next time, keep learning mathematics.